So hey everyone, and in this video we are going to continue with TypeScript. So till now we have covered a lot of important topics, but today we are going to continue with some more, and also a very important concept, that is oops is remaining. So we are going to cover all of that, although it's similar to JavaScript, but you can just consider this as a revision of JavaScript along with some new concepts which are available in TypeScript, right? So I'll just create a new folder here and I'll just name it as tut3, and that's it. And here guys, I would simply say we have, suppose, a file index.ts, and you can actually name anything else also. It's not compulsory to just name it index.ts, it's up to you, right? And then after that, till now we have got a lot of things, and what you can do is, if you want to get the source code, you can actually visit my GitHub profile. For that guys, I'm going to first of all show you some things like in the last videos we have actually covered the basics. You can see this was the basic. Then we also covered some important things like type, annotations, different kind of things which we had in TypeScript, right? So some things were actually remaining, so I would like to cover that also. So first of all, I would like to discuss call signature in TypeScript functions. So although we have covered functions, arrays and tuples in last video, but some parts are remaining, so I would just cover that today, right? So in TypeScript, a call signature is a part of defining the structure of function. That is, for example, if function is returning a string, an integer or things like that, if function is taking some parameters also, so you always have to define the function's signature, that means type of things. For example, I have a function, I would just say const add, and suppose this is a function which performs addition, right? And I'm just going to say we are going to provide two parameters. If I just talk about normal JavaScript, right, so it would work fine, and I would just return a plus b. But the problem here is you haven't provided any type here. Okay, so the problem here is you can like by default there is any type. So if someone provides string type as a parameter, what would happen if a, suppose, is a string and b is a number? So there would be again problems, right? So you know, in TypeScript, the benefit of TypeScript is you have types, right? By default we have any type defined. That means you can just assume the type of this a is by default any. That means either it can be a string, boolean, integer, number, whatever you want. But to be specific, in the addition case, what do we want? We want it to be a number, right? So we actually do this by simply writing it like this. Okay, if I talk about defining parameters, okay, right, that's what we do. And one more thing which I have already taught before is, I would say that what kind of data would this function return. So I would just say that the data this function would actually return is actually I would just say that the things which this function would return is actually again the number. Okay, so I would just say that it would return a number, right? So yeah, that's what I would say. So I'll just return a number, right? So this is fine. So if I just say I want to perform addition, so I'll just say console.log, I want to add these two numbers. What would happen if I go to my terminal and new terminal, and here guys, you would see that we have this, right? So what I would do is I would just simply write tsc. Actually we have already done this before, so tsc index.ts. If I just write this, actually the problem is I must be inside this tut3. So what I would do is I would just write cd tut3, right? Now I would simply write that, so you can actually see that a file here has been created, and you can see everything is fine. A function like this has been created and it's fine, right? So arrow function is actually converted into normal function, if you can see, right? This was an arrow function, and don't worry about this warning, this is just a warning, right? This is just a warning, and if you just close this, everything would be fine, right? So you can see that's how things work. But yeah, this is the normal method. But suppose you have multiple functions, like for example, you have one more function which does something else, for example multiply, but the types you know are same. If you provide two numbers, you want the result as a into b. So again, you can see the types are almost same, right? In similar kind of functions, what you can do is, instead of writing this again and again, what you can do is you can actually define a call signature. That means a signature for function which can be used multiple times. So for that, what you can actually do is you can simply write type, and then you can just give any name. So I would just say my func type. Okay, I'm just naming it like this, and I would just say, suppose if someone provides a as a parameter, and suppose someone provides b as a parameter, what do you want to return? You want to return a number, right? So I would just provide a and b as a parameter, and you would be returning number. And you also want to say a is what? A is a number, and B is also a number. That's it, very easy, right? So I've just defined that this would be, suppose, my blueprint, or suppose a picture how would the function take parameters and what would be the result. Okay, the result would always be a number and the function would be taking two parameters. Again, both of them would be numbers, right? So here's what I have said. Now instead of this, guys, what you can actually do is, what you can actually do is, you can simply say that const add, and I would just say you want to just define the type which this function must follow. So I just define the type, that is my func type 1, that's what we have defined, call signature, and then I would just write things normally, right? That's how actually things work here, and you can see that's perfect. Okay, so now suppose instead of this you have multiplication, so you don't need to write the types again and again. You can simply say again my multiply would be taking two numbers and returning two numbers, so I would just say two numbers, right? Similarly, suppose you want to do it for division, you can easily do it for division also, right? So divide, and again it would be taking two numbers and returning the division, right? So you can see that it actually made our task a lot easier. So that's actually the purpose of call signature. So a call signature describes the shape of a function by defining the parameters it expects and the return type it yields. So it's similar to how you define a function, but it's used to describe the function of like type of a function rather than its implementation, right? So that's how actually the call signature works. So now guys, we are gonna continue with another example. So what I'll do is I'll just cut this code and I'll just create a file here. I'll just name it as call signature tut.ts. okay, so I'll just save it here. Then what I'm going to do is I'm going to explain you some more topics, like what is enum. Okay, so guys, what we'll do is, like, instead of this, what we can actually do is, I would like to say, suppose I want to run this file only directly, would a JavaScript file would be created or not? Let me just show you, because I haven't taught that. Okay, so what I'll do is like, this is the file name, right? So what I'll do is I'll just copy, actually I would just press Ctrl F2 and I would just copy this, and what I would do is I would just simply write tsc and then I would just paste it. Okay, .ts. I want to run this file, so you can see as soon as I run this, a similar JavaScript file is created. That means index.js is not created, the file name similar to this is created, right? But suppose I make a change here. Suppose I make a change here, in any case, in any file you can do this, in any TypeScript file. Suppose I make a change here. Suppose I would just say, instead of this, I would just remove this. Suppose I want to remove this or do any change. Now next time when I want to run this, what I'll do is I'll again just type this, then I would just run my JavaScript file, which is here, right? Then I would just run my JavaScript file. So if I'm here, I want to run this, I would simply type node. Actually here I would just write JS, and here I would just simply write node. So to run JavaScript file, we have Node.js installed, so you can see it's running fine. But for every single change, you have to first of all compile like this using TypeScript compiler, then you can run the JavaScript file. So this is very annoying if you are building a very big project, right? So for now, if you are talking about just single file, suppose I am working on this file and I want to be make the changes automatically, I don't need to compile again and again. For that, what you can actually do is you can add a watch here, right? You can actually add a watch here. So what you can actually do is whenever you are running this, so suppose you want to run this, right? So I would just say we want to add a flag here, that is watch. So it started to watch. So for example, right now you can see it's like this, right? The JavaScript file is actually like this. So let's make a change. So suppose if I make a change, you can see now I actually made a change, so automatically this change is reflected here. That means you don't need to compile again and again, automatically things would be handled here. Remember, we also learned Node.js in this series, so you can actually check that, and there we learned about nodemon. So nodemon was that whenever you make a change, automatically server is refreshed without restarting. Like you don't need to start manually, automatically the server would be restarted. So similar to that, we have watch in TypeScript, right? Watch would simply compile the code into JavaScript code automatically. You don't need to do it manually, which we were doing before. Okay, so it saves a lot of time, right? So yeah, very good trick.